session. Greeting of the day. In today's class, we are going to see about a few PLC programming, PLC ladder programming. In such a way, it will be more helpful for the design of the mechatronic systems and it will be helpful for the future trends. So, from basic level, PLC programming, we have to see how far it will be helpful for our trends. So that we are going to see. So before going there, we want to understand few points how we are going to program the ladders and what are they. So I am naming this as an input as a contact or closed until it is given an input connection. It is at a normally open condition. When we are giving the connection, it is going to give the circuit, it is going to take the power from the power rail. We have named this as a power rail. Right? And this we have named this horizontal line as a rung. Right? According to this first rung, when the input has been given or processed or switched or sensed, if it is sensed, the output A is going to be activated. So from here the power will come here and then it is going to activate. So what I have written here, output A occurs when input 1 is occurring. Output A has been started when input 1 is sensed. This is one type. Now, here output B occurs. Output B is going to occur when input 1 and input 2 are occurring. Right? So according to this diagram, this is mentioned as input 3. So we can keep as it is. Input 3 is occurring. So what happens? Input 1 is occurring and input 3 is occurring, and therefore the power supply is going to input B, output B. So likewise. So here you see, this is normally closed contact. It means when at a nil position, the circuit from here it goes to the output. This is a normal position. When it is sensed, when it is switched on, then it is going to disconnect. And when it is going to disconnect, and it is going to become disconnecting this connection. Therefore, power will not move. The power won't go. It is stopped here. This power is not, because it is normally closed contact. When it is sensed, it is going to disconnect. This we are naming this as a break contact. So we are naming this as a break contact. This I am naming as a create contacts. This I am naming as create contact. So now this remaining two, this is the output. If the symbol is indicate, this is output. The symbol, this output we are using here. This inputs are we are using here, and this is we are using for this special functions. Design itself, it's a rectangle. We are using maybe for timer or otherwise for counter. Some timer counters functions are we are using for time, for how many seconds should be activated or after how many seconds it should be started. So such programs we can able to do. In the third rung, so we have talked input A will on. When input 1 and 3 are activated or sensed, then output B will come. This is in the AND functions. Now we see one more. I am giving an input 1 even though the power will be going and it is activating. Or otherwise I am giving an input 5, then also it is going to activate and then the connection goes, and it means in either or connection we can able to activate the output. Output C occurs when input 4 or input 5 occurs. This is OR function. Okay, so likewise some of the, at last I have the end run, so you should mention in such a way this program is closed, end of the program. Few we have to understand before going for the advanced systems. So now I have taken one example of I want a solenoid valve is to be activated if a sensor A is given as an input. What is sensor A? It is nothing but here. A sensor A is given as a input connection. Sensor A is given as input connection. When it is sensed, circuit is going to go here and it is going to activate a simple electrical switch. When it is switched on, it is going to activate a simple form. The light is to be come on. Light is to come on if there is no input is sensed. Light is to be on if no input is given. What we have to use, we are going to use this brake contact here. At the nil position, it is giving the power. At the nil position, you see, at nil position I have not even touched, not even sensed. The power circuit is keep on moving there. So here the circuit is keep on moving, and we are getting the light blink at the nil position. Now, when it is sensed, what happens? When it is sensed, it is going to break the contact here. It is going to break the contact here. Therefore, there is no circuit connection between the power rail and the light. So it is disconnected here. Therefore, it is going to stop the light. So by the program, light is keep on if there is no input. We are not given input. Input set means we are touching or sensing or switching on. That is input. I am not given input, but the circuit is keep on growing. So at a nil position. So such examples we can able to take. Next I am taking two switches are normally open and both have to close for motor to operate. The same thing what we have seen. AND function. See, this is an AND function I have given there. What happens? So, switch 1, two switches to be activated. Two switches are normally kept open. Now it is open. Two switches are normally kept open now. And both have to be closed. I am closing now. I am closing one. Power circuit come up to this one. And I am closing the second one. And therefore power goes to up to this point and it can able to reach. At first position, power cross and waiting here. When the switch 2 is activated, the remaining contact goes and the motor is on. So such examples we can able to do. Now you see, I want going for the second one. A lamp is to be switched on. A lamp is to be switched on. A lamp is to be switched on if there is an input from the sensor A or otherwise a sensor B. So nothing but it's a OR function we are going to talk. So sensor A has been taken. Sensor A has been taken. The lamp should be on. The lamp should be on. If sensor A is activated, power goes. And otherwise sensor B is activated, therefore also power goes and it is activating the bulb. So very simple somehow. Now the next one now. Either two normally open I have taken, either it is OR. Switches have to be closed. Switches have to be closed. For a coil to energize, this coil to be energized and operate an actuator. Where is actuator now? Coil has been energized. After that, I am taking this output as an input in the second rung. This is rung 1, we know. Rung 1, and we know this is the rung 2. So I want to activate this if the coil is energized simultaneously in forward direction. In next to that, I am connecting this coil name as an input here. You see, the coil name, the coil has been given as an input here for this connection. If the coil is energized, obviously here this connection will be closed. The coil output is taken as an input in the rung 1, rung 2. So this connection is going to activate the next one, the named as actuator. So it is activating here. So one output has been taken and given as an input and it is operated. So this coil can be activated with respect to S1 switch or otherwise S2 switch. Here the function, this function is OR function, parallelly connected. So this is one of the other example. Now I want to do a motor is switched on. Motor is switched on by pressing a spring return, very important word, listen. Very important word, spring return, push button, start switch. When I am pushing a S1, it is returning back, but it is going to on the motor. Connection is given to motor, motor is switched on, in immediate, and motor should remain in on. What I have to do? For that condition, what I have to do? Because we have given the spring return as a push button, it's not a switch, not as usual home switches. And push button I am using. When it is pushed, when it is pushed, the motor will on. And when I am releasing, the circuit connection to the motor will be disconnected. That is the function of spring return push button. Therefore, what I am doing, when this connection has been pushed, here I am pushing, has been connected. Now the connection has been from the power rail reaches the motor. Simultaneously, I am connecting this motor's output as the input here. I am doing the latching process. I am connecting the motor, and this has been from the power rail. I am taken separately the secondary connection and I am giving to the motor again. What happens? Even though this connection is not there now, because it is a spring return, it is pressed and it came back. But in the meanwhile, this motor connection is again latching to the as input given from the power rail to the motor itself again, latching. Therefore, the power goes from here and it is keep on running. The motor is keep on running. It is in the keep on remaining in the on position. So this is named as a latching process. So that's how we can able to do. So S1 is a spring return push button. We understand that is a push button. Now you see, an automatic machine is switched on by pressing a spring return. Here also we have used the spring return of push button to start a switch. So switch output has been started, and the machine remains on. Machine is going to remain on the same program. This program I am extending remains on until the another spring return push button is stopped, is pressed. What I have to do? I am pressing one, motor is activated, and I want to press again one more switch of S1. This is S2. This motor should terminate. What I am doing? First, you will consider the volt diagram in this setup. In this setup, S1 is there. I am pressing. The connection is going there. The connection is going, and it is connecting there. Okay. Now the output is on. You should keep on running. I am doing the latching process. One output has been taken here, and latching also done. And my condition is to switch off the motor when the second push button is pressed. What happens then? When second push button is pressed, this circuit to be disconnected. Then only irrespective of the output contact given by the latching process should not work. Therefore, I am giving a brake contact. I am giving a brake contact here. What is brake contact? When the input is given, it is going to brake. When the input is given, it is going to brake. That is called a brake contact. What is given here? When the S2 spring button is switched on, another spring button is pushed. Another spring button is pushed. What happens? It is going to brake. Now I have pressed. Let us consider I am pressing here. And when I am pressing here, what happens? It is braked now. It is braked and it has become an open contact. The closer brake contact is pressed and it become an open contact. So what happens here? There is no connection here. There is no connection here, and it is not, power source is not supplying. Power is coming here. Up to this point, this power is there. But S2 is a brake contact. When I am pressing, it is going to brake. It is braked the path. Therefore, the power source is not going to open. It means the motor, it is not running. So likewise, we can able to plan some other programs also. Now, somehow we are getting complexities. A barrier gate at the entrance, we are going with the parking areas, a barrier gate is there, it should open and close. You will see. A barrier gate at the entrance of an institute has to be controlled by the PLC. Now we have taken the PLC. Now, a gate has two proximity sensors to sense, maybe in or maybe out. Two proximity sensors to sense the person at both sides of the barriers. On left side and on right side. At any sides, when the person is crossing, it's going to detect the person is present near the barrier. Now, a control is given to security. Control is given to security whether manually the security can open the barrier in such a persons can travel. Otherwise, when the person is sitting nearby, and also there is sensors in the post itself. Otherwise, the sensor in the post itself, it means the barrier post itself, to detect whether the barrier is down. What happens? If the barrier is down, when the person comes, it can automatically open. Otherwise, the security can see the person and he can click in such a way that the persons can permitted to go out. Therefore, we have sensor at the both ends. That also. So, sensor 1, sensor 2, controlled by the sensor, controlled by the security, controlled by the automatic post. Now, device a suitable PLC system for opening and closing of the post barrier. What we have to do? You see, sensor 1 and sensor 2 are the proximity sensors sensing a person. Sensing a person we have done. S3 control with the security. S3 control with the security. S4 sensor to be detected by the barrier whether it is down, then it should open. Open the gate. Output is only one. It should open and close. It should be open. And a person comes. That's our program. What I am doing now, S1 maybe left or right. Push the sensor receives the person is present. Person is present in S1. Or otherwise, person is present in S2. So this is the R function. At any cases, the circuit is going to activate a internal relay 1. That is not output. We have the condition yes. Therefore, output at last. Internal relay 1. Now, in such cases, internal relay 1 will activate this IR1, and then it is indicating that person is present. Now, who has to decide? It has to be decided by the post. It has to be decided by the security. Now this S3 controlled by the security. Security gives the permission, he can move. And then the post also detects he is coming very near. And now internal relay coil 2 is activated in such a way, this internal relay coil 2 gives the connection to the IR2. What happens then? Now the power rail from the here, it is ready up to this point only. When the IR2 is detected, when the security approval and the post approval is done, and then gate post is going to open. So in such a way, somehow the systems we can able to create to close and open the barrier system. So this is one of the example. Now, the summary. In today's class regarding the PLC systems, we have seen about the contacts, about the ladder program, about the contacts, and about the brake contact, and about the relay coil, and about the timer, about the counters. So these things we have some with respect to advanced mechatronics approaches we have seen. The remaining part of the subjects we'll see you in the next session. Thank you.